This is a very interesting question. A boy throws a ball with a velocity v0, that is 10 root 2 meter per second at an angle of 45 degree as in the figure. After collision with the wall, the vertical component of the ball velocity is unchanged and the horizontal component is reversed in direction. Where does the ball hit the ground, taking g as 10 meter per second square? So let us first of all draw the figure which is given. So it is given, let us suppose this is the ground and this is the building, and ball is thrown at a point which is at a height of 2 meter. Let us call this O. It is thrown in this way and it strikes the point P. After striking the point P, it moves in this direction and hits the level ground at suppose point Q. Let us call this as M, and the angle of the projection, this is U. This angle of projection is given as 45 degree, and the distance of this wall from point O is given as 4 meters. Let us call this point as N. So this is the diagram, and in this case we are going to find out where this ball hits at point Q. So this distance we have to find out. So let us divide this question, or rather we can say solution, into two parts. In the first part, we are going to find out motion of the ball. We are going to discuss motion of the ball from the boy, motion of the ball from boy to the wall. So this is the first part. So in this case, the horizontal component of velocity let us say this is ux, given as u cos of 45. So we can see that u is given as 10 root 2, cos 45 is 1 by root 2. So root 2 cancel out. We get the horizontal component, that ux will be equal to 10 meter per second. Now the horizontal distance traveled in the time t. Next we find out horizontal distance traveled by the ball in time t, which will be equal to ON. So this ON will be our horizontal velocity multiplied by time t, and excuse me, ON is already given as 4, so we can write the 4 ux is 10 multiplied by t. So from this we can write that t will be equal to 4 by 10, or this can be solved as 2 by 5 seconds. So we can say this is our time of flight before hitting the ball. Now within this time period, the vertical distance traveled by the ball. Vertical distance traveled by the ball in time t, and this will be equal to Pn. So we can use the formula for the kinematics, that S of y is equal to u by t plus half a y t square. So we can find out u of y. U of y will be equal to u sine of 45. U is given as 10 root 2. Sine of 45 is 1 by root 2. Root 2 cancels out. So we get this as u of y is 10 meter per second, and acceleration due to gravity A of y will be equal to minus g, which is given that we should take it as 10 meter per second square. So if you substitute the values, we get uy is 10, time we already know is given by 2 by 5, minus half is 10 into 2 by 5 whole square. So we can say that Sy, that is our Pn is equal to 16 by 5 meters. This is the value of Pn. Now we come to the second part. Second part states that motion of the ball from the wall to the ground. You can write motion of the ball from wall to the ground. So in this case, the vertical distance traveled by the ball will be PM. The vertical distance under this condition, vertical distance traveled by ball in time capital T, let's consider it. So this will be equal to PM. So we can use the formula Sy is equal to u by t plus half a t square, and we are going to substitute the values, and first of all we have already said that time t is equal to capital T, and Sy is nothing but our Sy is represented as Pm is Pm. So Pm will be equal to Pn plus Nm. So we already find out that this is equal to minus, okay, it will be minus because it is in the opposite direction with respect to x. So this will be minus 16 over 5 plus 2 meters, and this will be coming as minus 26 upon 5. So this will be our S of y, and A of y will be equal to minus of g, that is minus of 10, and u of y will be equal to v of y, and that is equal to 6 meter per second. It is stated that there is no change in the velocity in the one direction. So we put the values, we get this as minus 26 upon 5 is equal to 60 minus half into 10 into t square. So you will get this quadratic in t square, 5t square minus 60 minus 26 upon 5 is equal to 0. So using the basic formula, we can find out what will the value of t. So we can write t is equal to minus 6 plus minus b square, that is 25, and minus 4ac, that is 4 is 5, and that is 26 upon 5 divided by 10. So we consider only positive value, so we can write it here taking only positive value. We had t is equal to 1.78 seconds. This is the time. So during this time, we can find out what will the horizontal distance traveled. So we can say horizontal distance traveled in time capital T, and that distance will be equal to mq. So we can write that this will be equal to ux into capital T. Ux is u cos of 45 into capital T, and this is our 10 and time is 1.78. So we can say the distance, that is mq, will be equal to 17.8 meters. So this is the point, or rather we can say this is a distance at which the ball is going to come back at the ground again. Thank you.